Good afternoon, everybody. Welcome to our webinar from Angst+Pfister Sensors in Power in cooperation with RoboteQ for the new Generation 4 controllers. I think we are waiting 1-2 minutes more because some people are still coming in. So okay, let's start here. The others will come probably a little bit later. So welcome to the webinar. I have here the agenda for today. Short introduction about Angst+Pfister Sensors in Power. Then we have the presentation about the RoboG4 controller. You see there the subtitles, introduction, performance, integration, reliability, and value. And at the end, we have a Q&A session. I want to welcome my colleague Daniel Vogler. He's the product manager from Angst+Pfister for the drive technology. But I also want to make a special welcome to the guys from RoboteQ. We have Cosma with us. He's the CTO of RoboteQ. We have Ethan. He asked me to call him Ethan. He is the field application engineering manager. So if you need support in the future, he is your right contact. And hopefully we have also Dimitri with us. He is the sales manager for Europe. So also the guys from RoboteQ will be available to answer your question in detail at the end. Here a short history. Not everybody knows Angst+Pfister Sensors in Power. We were founded 1987 as Pevadron in Switzerland. 2006, Angst+Pfister acquired Pevadron, but we kept the name Pevadron. In 2017, we moved the drive technology from our mother company Angst+Pfister into Pevadron. Since 2018, we have a cooperation with RoboteQ, and we are the official distributor for Germany, Austria, and Switzerland, but also for Eastern Europe. And 2021, we were renamed from Pevadron now to the name of the mother company, Angst+Pfister, with the very long extension of Sensors and Power. Okay. A little bit about the product range we have in our portfolio. For sure, the drive technology. These are the controllers we are talking later on, but we have also motors in our program. So if you need motors, we have them also available. Some other products in our portfolio are geometrical sensors, so encoders, power supply, electronic components, especially DC-DC converter, pressure and load sensor, gas and humidity sensor, current sensors, and temperature sensors. So if you have requests for one of these products, please feel free to contact us. Here, some rules for today. We will show a presentation of the RoboG4 controller. We will stop the presentation at several points to give you some time to digest what you have seen and heard. And we will also already answer some of your questions. You can continuously write questions to us. you will find on the right bottom of your screen, you see the question button. If you click there, you can continuously ask questions. They will be stored, and some of them we will answer during the presentation. Some of them we have some time at the end of the presentation. We will record this presentation, and we will put it later on also on our website, so you can also review what you have seen. Okay. So, Clara, can you move to the presentation, please?
Welcome to this presentation of RoboteQ's new 4th generation RoboG4 servo drives. Over the next few minutes, we will show you the technologies and products we have engineered to help make your project a success. After a brief introduction, we will focus on the performance, the ease of integration, the reliability, and the exceptional value designed into our drives. Headquartered in Arizona, USA, and with a research and development center in Athens, Greece, RoboteQ grew to a leadership position in the field of servo drives, primarily in the fast-growing mobile robot market. In 2020, RoboteQ was acquired by Nidec Corporation, the world's largest maker of electric motors and drives, propelling it onto a much steeper growth trajectory. RoboteQ's original creativity and energy is now augmented by Nidec's almost limitless resources. Our team of engineers and scientists is several times larger already and is integrating leading-edge technologies from Nidec's corporate advanced research centers. Investments in design, tests, and validation tools, and the rigorous methods that go with them, further advanced our drive's quality and reliability. With factories all around the world, we can satisfy the largest orders at the best possible costs. RoboteQ's 4th generation RoboG4 drives, shown in this presentation, are the product of our new capabilities as a member of the Nidec family. RoboteQ specializes in the design and manufacturing of low-voltage advanced servo drives. The range includes 3 main families of single-channel and dual-channel drives, from small to medium and large. A major new addition are motors with integrated servo drives. All those drives are compatible with each other, and so can scale with the application. The drives support all common motor types, SPM or IPM brushless motors, DC brushed motors, and AC induction motors. RoboteQ drives offer, among other things, world-class performance, functional safety, and superb connectivity. RoboteQ drives have feature sets that make them particularly well-suited in a wide range of motion control applications. Mobile robots for material handling and warehouse automation are applications where RoboteQ's dual-channel drives, battery operation, STO, and paired motor and drives are key requirements. Agricultural robots share many of the same needs, in addition to stronger resistance to shock and vibration and the need to operate at wider voltage ranges. The peer-to-peer communication and the scripting capabilities of our drives make it possible to implement complex kinematics algorithms like those needed in omnidirectional robots. Personal mobility is another major application enabled by our drive's very efficient support for integrated permanent magnet motors, AC induction motors, and regenerative braking. As watercrafts are increasingly going electric, our driver's sensorless sinusoidal commutation ensures quiet and efficient operation. One of the major improvements in Generation 4 drives is the support for the Profinet and Ethernet IP industrial field buses. RoboteQ drives and integrated motor drives can now be inserted in large PLC-based factory installations. Likewise, the addition of the EtherCAT field bus on our drives opens the door to multi-axis robotic applications that depend on very tight and precise motor synchronization and advanced control algorithms. Precise positioning, multi-turn encoders, advanced algorithms, and Ethernet are also defining requirements in many test and production machines. Finally, our new drives and integrated motors are an excellent fit in the emerging field of medical robotics, thanks to their high precision, low emissions, and high reliability. Let's now take a closer look at
So we stop here for a second. So this was the introduction. I forgot to add, if you ask questions, and for those here, they prefer to write them in German, please feel free. We will translate them. So no problem. Okay. We will continue now. The next section is approximately 7 minutes, and you will see something about the performance, and we will make a stop also afterwards. Okay. So if you have questions, please continuously write them down.
Let's now take a closer look at the major performance enhancements in our new drives. The most significant change is the use of the G4 processor. This MCU runs 3 times faster than before and includes on-chip motor acceleration hardware. This allows us to create new, better, and faster algorithms that we'll describe in more detail in a moment. Yet the processor has memory and power to spare for future capabilities. Another important development is the support of the EtherCAT, Profinet, and Ethernet IP field buses. These industry-standard protocols are handled by a dedicated communication coprocessor, leaving the main processor free to focus on motor control tasks and thus improving total system performance. Here we see a practical example of how the faster processor dramatically improves performance compared to a third-generation drive. The purple line shows a command requesting an instant torque change from plus 30 amps to minus 30 amps, and 30 milliseconds later back to plus 30 amps. The third-generation drive with its 1 millisecond control loop performs imperfectly at that speed. The control loop now runs 16 times faster in RoboG4 drives. The output current tracks the command with minimal delay and practically no overshoot. When a steady command is applied, the fast loop also instantly corrects the current in case of sudden load changes. The current always remains within safe ranges, resulting in fast protection and increased reliability. The control loop now runs 16 times faster in RoboG4 drives. Step response was 4 times faster and settling time twice as fast with 4% lower overshoot. Here we see the details of the new control loop architecture and some of its other important enhancements. In addition to the fast current loop we just discussed, control is now composed of 3 cascaded loops for position, speed, and current, each with its own PID gains, resulting in easier tuning and optimal performance. Offsets and feed-forward blocks have been added to improve system responsiveness. A notch filter has been added to tune out vibration at the system's mechanical resonance frequency. A mechanism has been added to compensate for the magnetic cogging caused by the rotor teeth and the permanent magnets inside the motor and smooth out the rotation at very slow speeds. Current loop feed-forward uses the motor model to instantly compute and apply the output needed to reach the desired torque. This increases the system's responsiveness and further reduces overshoots compared to the PID loop alone. Robots typically operate over a wide range of load that can change on the run. Adaptive control continuously observes the system's inertia and applies new gains on the fly, resulting in optimal performance at any load point. Our scientists are continually working on new and improved algorithms, maintaining our drives at the leading edge of motion control technology. Another exciting new feature is automatic field weakening. Here is a typical electric motor torque speed curve. With field weakening, the motor can reach a significantly higher maximum speed. It also produces additional torque at the motor's rated top speed. This is entirely and automatically managed by the drive, essentially extracting more performance from the same motor at no added cost or effort. Precise rotor sensors are essential for proper sinusoidal commutation. Some sensors are not perfectly linear, and any such imperfection directly translates in imperfect current, and therefore inefficient motor operation. RoboteQ drives can store a linearization table to correct these imperfections. With the correct rotor angle reporting, the current is now perfectly sinusoidal, resulting in smooth and efficient motor rotation. New automatic setup and tuning features have been added to save precious effort and time. The rotor sensor is a key component of the system, as we just saw. In less than a minute, the new sensor setup function automatically determines the sensor mechanical offset, its linearity, and polarity. The data is then stored in the drive's configuration memory. The motor is typically ready to run immediately and efficiently after this step. The motor's internal resistance and DQ inductances can be automatically measured by the drive. This information is often missing from the motor's manufacturer's specs. It is, however, essential for tuning the control loops and for the implementation of model-based algorithms. The current loop can be tuned in a matter of minutes as well. For a desired torque bandwidth, the drive and PC utility automatically determine and store the loop's correct PI gains. After this step, the output current will follow torque commands with minimal delay and no overshoot. An automatic process is also provided for measuring the inertia and friction of the system. With this data, the drive then computes and applies the speed loop's PI gains for a desired response bandwidth. Speed loop tuning is more accurate and performed significantly faster than before. Enabled by their higher computing power, the drives now support several kinds of special AC motors. Thanks to their lower cost and high-speed range, internal permanent magnet or IPM motors, now widely used in electric vehicles, are growing in popularity in many other applications. IPM motors require that the torque and field currents, ID and IQ, are regulated optimally depending on the motor's actual speed and torque demand. The drive performs this algorithm using the motor resistance and inductance that were measured during the auto-characterization process, making IPM motors as simple to drive as traditional brushless motors. Significant savings can be achieved by eliminating the rotor sensor altogether, especially in applications with motors driving propellers, such as watercrafts, drones, or fans. In these sensorless applications, the drive can estimate the rotor's angular position, considering the motor's theoretical model and the actual measured current. The result is silent motor operation, with very efficient field-oriented control. AC induction motors, with their simpler construction and lower cost, are an attractive choice in transportation and some robotic applications. Using the automatically measured motor characteristics, the drive runs a model-based algorithm to estimate the rotor's slip and control the motor with great accuracy. Let's now look.
So let's have here a short break before we go to the integration. I got a remark that there is a little bit delay in the audio versus the video. So please excuse this. We cannot influence it at the moment. Okay. Again, I recommend if you have questions, remarks, whatever, please send us the questions. So far, there's no question. I got the other remark that the delay seems not be at all the computer, so maybe it's a local issue.
Let's now look at some of the features that make RoboteQ's drives among the easiest to use and fastest to integrate. First, the drives are highly configurable and can therefore work with practically any type of brushless motors. Much of this flexibility comes from the wide range of supported rotor sensor types. These include Hall, quadrature encoders, analog Simcoes, resolver, and SSI. The dual-channel versions, with their built-in differential algorithm, are particularly effective in mobile robot applications, where power is balanced between the left and right wheel to move and steer. The motors are synchronized within the drive. In case of deviation in one motor, the drive can instantly act on the other motors as needed. All RoboteQ drives have user I/O that can operate in many ways and be used for practically any purpose. Scripting is a unique capability of RoboteQ's drives that enables unprecedented flexibility. We'll be discussing it in more detail in a moment. All drives have built-in PC connectivity via USB or serial. This allows the user to change configuration and monitor the drive in a non-intrusive manner while it is operating. The drives are backed by extensive documentation. Wiring, connector printouts, and electrical specs are described in a 10 to 20-page product-specific datasheet for each drive model. All common features, operating mode, and commands are discussed in the drive's reference manual. Scripting and networking have their own dedicated manuals. RoboteQ offers APIs and drivers to help interface the drive with user applications, or for integrating into systems running the ROS robot operating system. The drives are supported with the free RoboRun PC utility. The tool has been updated to support the drive's new features. Interactive menus have been added to perform the automatic motor characterization and sensor setup. A new wizard steps the user through the automatic speed and torque loop tuning, cutting the effort from hours to minutes. To help monitoring and troubleshooting, the utility features a new powerful multi-channel chart recorder capable of viewing any of the drive's parameters with a time resolution of 1 millisecond. This is more than 20 times faster than the earlier version. The utility incorporates a development environment for writing, simulating, executing, and debugging micro-basic scripts. Finally, the utility includes the firmware updater necessary to install the latest advances. Firmware can be installed via USB, RS-232, RS-485, and now also via CAN bus. Field bus connectivity is another area of major progress in RoboG4 drives. CAN bus is the first field bus supported since RoboteQ's early generation drives. With Generation 4 comes a fully interoperable version of the CAN Open DS402 protocol, making the drive a direct plug-and-play product in these installations. RoboteQ drives support 3 additional CAN bus protocols. RoboCAN is a mesh network allowing any drive to exchange data and commands with any other drive, directly without the need for a central PLC or computer. MiniCAN is a simplified subset of CAN Open. RawCAN is a low-level protocol which can be used together with microbasic scripting to implement any protocol. Modbus is a legacy communication protocol. ASCII and RTU Modbus is available on all drives with RS-232 and RS-485 ports. Modbus TCP is supported on all drives with Ethernet connection. Profinet and Ethernet IP field buses are now available in some 4th-generation drives. These Ethernet-based buses primarily integrate with PLCs in factory automation applications. Profinet is the main communication bus of Siemens PLCs and is therefore dominant in Europe, while Ethernet IP is this of Rockwell PLCs and therefore dominant in North America. EtherCAT is now also available on selected new drive models. EtherCAT is a high-performance field bus with microsecond-level synchronization between nodes. It is a key technology for multi-axis robotic systems and machines. RoboteQ supports CAN Open over EtherCAT, mapping the DS402 protocol inside EtherCAT data frames. One of our drive's most unique and powerful features is the ability to store and execute user programs. This capability is the equivalent of combining the drive functionality and this of a PLC or single-board computer into a single unit. MicroBasic is a simple BASIC-like language that is learned in minutes. Script can be simple or elaborate and can be used for various purposes. For example, implementing custom CAN bus protocols, on-the-fly loop gain changes, operating mode changes, or custom safety strategies. In many applications, they can completely eliminate the need for an external PLC or computer. This RoboteQ customer, for example, scripted the entire kinematics algorithm for a 4-wheeled Mecanum drivetrain. Users of RoboteQ's 3rd-generation drives can easily migrate their application to the new generation drives. All the company's most popular drives have been updated or will soon be. All changes are under the hood, with no change to any physical properties, such as enclosure, dimensions, and mounting, and no changes to the connector types, positions, signals, and pin assignments. The new generation drives differ by the G letter added to the original part number. Because of the significant improvements made to the control loops, the new drives will need to be tuned again. This step is made quicker and easier thanks to the drive's new auto-tuning capabilities. RoboteQ's RoboG4 drive technology is at the heart of a new line of motors with integrated drives. These space-saving, easy-to-install, and easy-to-service units come pre-configured and tuned to deliver a true plug-and-play experience. They are composed of a long-life precision Nidec motor with integrated magnetic encoder. The first member of the family is a 60mm frame motor available in 2 power ranges. Integrated motor drives with smaller and larger frame motors are currently under development. Because they are G4-based, they support all the advanced features and algorithms discussed so far in this presentation. The products feature an innovative mechanical design, resulting in a very compact assembly, with efficient cooling and solid environmental performance. These integrated motors are typically mounted away from other motors with which they need to cooperate, and away from the main computer or PLC that supervises their operation. Connectivity to field buses is therefore essential. Support is available for CAN Open, EtherCAT, Profinet, and Ethernet IP. All ILD integrated motor drives support safe torque off. They can be made to reliably stop producing torque using a pair of redundant command signals. STO is a critical functional safety requirement in applications where malfunctions can cause harm to persons or property. For mobile robots and AGV applications, kits including drives and motor offer a fast path to integration success. The kits contain a pair of motors with gearboxes and wheels, one dual-channel drive that is preset and tuned for these motors, and cable assemblies. Kits are available in 3 sizes of motors and drives for robots weighing up to 500, 1,000, and 2,000 kilos. However easy we make our drives to use, there is always a time where personal human health is needed. RoboteQ has teams of support engineers in North America, Europe, and Asia ready to help with system dimensioning and product selection. Once your project is started, you can count on our engineers to assist you in your integration efforts through remote access into your application or with on-site consulting. We are dedicated to your success because we can only be successful when you are successful too. Let's now see some of the changes.
So let's stop here for a while because luckily we got a lot of questions during this section of integration. The first one was, what are velocity and position loop update rates? I think Cosma already answered this. The new processor is working with 16 kilohertz, so it's 1 millisecond for the speed loop and 1 millisecond for the position. Cosma, are you online?
Yes, I am.
Yeah. You can see the next question. When will the new version of RoboRun Plus be available for download? The website still only offers version 2.1, which doesn't support generation 4 motor controllers.
Yes, so I just asked the question to my team. I'm told that you should have been there, so we're going to be updating quickly. However, we have a beta version that we can hand out to you. So we'll do it both ways. We'll send it to you, and also going to push to have it live maybe this week or next week. I'm told we have something ready to share.
Okay, so the software update should be available in approximately 1 week, let's say, end
Yes.
of March, beginning of April. If you need a test version upfront, please send us a short email and we can share it with you.
Yeah, I think we have Kevin's information. We can just send him.
Okay.
So we'll let's follow up with that.
Okay. Next question: when will be sensorless sinusoidal commutation be available for FBL 2360?
Right. So first, this is only a G4 feature. So we're gonna have to go to the G4 for there would be the FBLG 2360. Here too, this is something that we have right now on hand. We prefer at this stage to release, let's say, on a one-on-one basis. We don't want to publish it yet because Sensorless is pretty tricky. You have to have a perfect tuning, a perfect match with the motor. So we really want to work with you. Once you have that controller, or if you have it, then let's touch base with our FAEs to discuss how we can share with you the firmware for it.
Okay. Next question. Hi, is the new drive helping closed loop torque mode setup operation with simple Hall sensor brushless DC motors? We had issues doing this with current GBL 1860 drive.
Yeah, the short answer is yes. The setup, the automated setup works with any kind of feedback sensor, so there's no restriction there. Again, the only restriction is that this feature is one that is on the G series, on the new one. And actually, in this case, the RGBL is a single channel, and it is not yet available in G version or in G4 version. However, the GBL2, which is a dual channel product, which also can be configured as a single channel product, this would work.
Okay. Next question. Can use the new controller as a master controller for controlling two others?
Yes, the answer is yes. Typically we'll be using obviously a communication backbone like a CAN bus, and then you'll be using scripting so that you basically decide on the strategy on what exactly the master should send to the slave and when. For example, if you look at the presentation, you remember that we discussed scripting, and we had that Mechanum robot. This was a case where we had a master and slave configuration, and one was doing all the calculations, and the second one was just following the instruction of the first one.
Okay. The next question is something I already expected, Cosma. Will controllers for brushed motors be updated to G4 anytime soon? I think it's not only for brushed motors, but also for the AC motors. So
yes. So the short answer is yes. Of course, now you're going to ask me for a date, and I don't have a specific date. But the important thing I want to share here, the G4 functionality is really more important for the brushless. That's where you need to have the more powerful processor, the more complex math and things like that. So I guess, yes, the answer is we will have it by this summer. But again, it's not something that is as necessary as in terms of benefits, if you wish, as on the brushless, which really the brushless needs the high performance, the brush does not.
Okay. So, but Cosma, I remember well, you told me last time that you have the development already on the desk. It's only a matter of some weeks or months.
It's only a matter of really a matter of will, if you wish. It's because it's you know, the Gen 3 and the Gen 4 is really using the same software. It's the same processor, just a faster version of that processor, a much faster version. So I don't want to diminish the benefits. So there's really not much work in making the brushed. It's just that we have not seen the demand, but we know it's coming. So it is on the roadmap. And honestly, if you want it faster, just let us know, and we can just make it happen a bit quicker.
Okay. So place your orders, then they will be available.
Right.
Okay. The next question, do all G4 drives support IPMs?
They do. They do. In fact, to be honest, even the F3, the old one, do. But absolutely, the Gen 4 do support IPM.
Okay. And last but not least, when G4 controllers with Ethernet are available, small version?
Yes, so right now Ethernet is available on the G series, which is the big one, and on the F, which is the medium. There is no, well, let me take that back. We are going to have the F series with a new version of Ethernet, which is going to be a module cable of the EtherCAT and Profinet IP, and of course you can do regular TCP/IP. We have the smallest model, which is the SBLM G1, and this one also has a socket for Ethernet, EtherCAT, Ethernet IP, and Profinet. And those, by the way, when you're asking when, yeah, those are coming in the coming months, before the summer. They work in the lab. We have prototypes. They are being validated, and these will be released soon.
Okay, good. So these were so far the questions. So I think we can continue with the presentation and go to the section of reliability.
Changes we made to make our new drives among the most reliable in the industry. First, the power stage has been strengthened with a combination of hardware circuitry, improved PCB layout, and firmware. The processor and power MOSFETs are protected against higher voltage surges than earlier versions. The short circuit and overload protections are now immediate and effective in all conditions. Thermal protection also has been improved with the addition of an I²T algorithm, which throttle the maximum allowed current based on a theoretical thermal model of the drive. Additional protection is now present on all connections to the outside world. Extra attention has been given to the communication lines since they typically travel further distances and are therefore more exposed to high voltage potentials. System-level protection looks for and protects against faults in the drive and the components that attach to it. Many such protections have been added to detect faults with sensors, loop following errors, motor stall, and others. Every time a fault occurs, the drive records the voltage, current, and temperature at the time of the event. The log can then be examined offline. This unique feature greatly helps troubleshooting. The new drives have significantly higher immunity to external disturbance, such as a common mode noise or electrical noise caused by other drives in the system. EMI emission has also been reduced. Each drive design undergoes rigorous and extensive validation tests, including high G shocks, vibrations, thermal, and environment testing. Drives are then continuously cycled through their full temperature range under load for 40 days. All new drives support safe torque off. STO is a critical functional safety requirement in applications where malfunctions can cause harm to persons or property. With STO, the drive can be made to reliably stop producing torque using a pair of redundant command signals. RoboteQ's STO circuit has been evaluated and certified by TUV. It can therefore be trusted to always work, even in the case of a single component failure. While STO is a must-have requirement, it does not cause any braking and is therefore not entirely safe when applied to a moving, heavily loaded robot. With the motors floating and only friction to slow them down, the robot will coast uncontrollably for several meters before stopping. To solve this challenge, RoboteQ has developed a safety electric braking switch that works in pair with the drives. This patented device is connected in parallel with the drive and motor wires. When the safety PLC commands the torque to go off, the switch passes on the STO signals to the drive, which in turn floats the drive's output. The switch then shorts the motor leads using redundant solid-state relays to cause a strong electrical braking and stop the robot up to 10 times faster. After a delay, the mechanical brake is engaged, keeping the robot immobilized. Let's now see how our drives offer the value that you need to compete.
Sorry. Before we go to the last section of value, we got one additional question, and this is, do you support PWM brake control?
Yeah, the answer is yes. It kind of depends on the model of the product. So that you can look at the end of the presentation. We have a table, and I think we show which products support and which does not. But this is a feature that we are increasingly implementing in our products.
Okay, but by the way, we are storing all these questions, and we will write you an email with all the individual answers to the one they asked. So, yeah. Okay, let's go to the final portion of the presentation.
Pete. When compared to drives with similar performance, features, connectivity, and quality, RoboteQ's drives are the market's most competitive. Lower cost is designed into the product. The drives are true single-board designs, requiring no expensive and cumbersome add-on or breakout board for their use. They are cost-optimized without compromising performance or quality, using common multi-sourced components and connectors. In dual-motor systems, one dual-channel drive always costs less than two single-channel drives. Simplified installation and wiring bring system cost further down. In the case of integrated motor drives, Nidec is one of the few companies in the world that fabricates both the motor and the drive. The integrated unit therefore costs less than buying the motor, encoder, drive, and cables separately. Further savings are achieved by their lower installation and service costs. With 150,000 employees, $15 billion in sales, and plants all over the world, Nidec is a manufacturing powerhouse. Our global purchasing power ensures that we buy at the best possible price and always get priority treatment from our suppliers in times of component shortages. We manufacture in very high volume at the lowest cost and pass these savings to our customers. We deliver dependently, whether you buy hundreds or tens of thousands of units. You can depend on Nidec and RoboteQ to be on your side over the long term as well. Our drives are periodically updated and maintained, and thus avoid obsolescence. Today, we have many OEM customers that we supplied without interruptions 10 years after they installed their first RoboteQ drive. This concludes our technology introduction. Let's now look at the Generation 4 initial product offering. Looking into early 2023, there will be a total of 6 RoboG4 products available. 2 dual-channel and 2 single-channel drives in the S family, 1 dual-channel drive in the F4 family, 1 dual-channel drive in the high-power G family, and 1 integrated motor drive. Before jumping into the details of each product, here's a recap of how RoboteQ drives are named. The scheme is quite simple and logical. Understanding it makes it possible to guess the main characteristics of any RoboteQ drive. The first letter is the product family, in this case S, F, or G. The next 2 letters determine the motor type, BL for brushless, DC for brushed DC, and IM for induction motors. The next letter is present only on some drives to define a connectors variant. Drives with the letter M in that location use Molex I/O connectors. The G means it is a 4th generation drive. The first number is the number of channels. The following digit is related to the number of MOSFETs, and therefore to the power level of the drive. The last 2 numbers are the drive's voltage rating. Several digits can then be added to identify optional features like single-channel variants, safe torque off, or field bus type. The 2 single-channel members of the S family are the SBLG1360 and the SBLMG1360. Both have the same dimensions and similar amperage rating. Both support STO. The SBLG1 is rated 30 amps max and 20 amps continuous. It uses a D-sub connector and screw terminals. It has fewer features and is lower cost. The SBLMG1 is rated 40 amps max and 20 amps continuous. It uses Molex I/O connectors and fast-on power terminals. This drive can accommodate modules for connections to Profinet, Ethernet IP, and EtherCAT field buses. The table shows all the drive's features side by side for easy comparison. The two dual-channel members of the S family are SBLG2360 and SBLMG2360. Both have the same dimensions and are rated 2 times 30 amps max and 2 times 20 amps continuous. Both support STO. Both can be ordered as single-channel variants with twice the amperage or as 3-channel drives for brushed DC motors. The SBLG2 uses a D-sub connector and screw power terminals. The SBLMG2 uses Molex connectors for I/O and power. The table shows all the drive's features side by side for easy comparison. The FBLG2360 is the only member of the F family. This dual-channel drive is rated 2 times 60 amps max and 2 times 40 amps continuous. It supports STO. This drive can accommodate optional modules for connection to Profinet, Ethernet IP, and EtherCAT field buses. It can be ordered as a single-channel variant with twice the amperage, as a drive for induction motors, or as a 3-channel drive for brushed DC motors. The table lists all the drive's characteristics. The GBLG2660 is the only member of the G family and is the highest-powered drive in RoboteQ's catalog. This dual-channel drive is rated 2 times 180 amps max and 2 times 120 amps continuous. It supports STO. The drive uses D-sub connectors for I/O and communication, Molex connectors for sensors, and high-power screw terminals for power supply and motor connections. It can be cooled by conduction, convection, or even water-cooled in very high-power applications. It can be ordered as a single-channel variant with twice the amperage, as a drive for induction motors, or as a 3-channel drive for brushed DC motors. The table lists all the drive's characteristics. This table summarizes all the RoboG4 drives and lists their features side by side for easy comparison. The ILD60S is the first of a series of motors with integrated drives that will be introduced starting in 2023. This product can be assembled in several different ways. At the core is a 60mm frame motor with built-in magnetic encoder and a RoboG4 drive. The variance chart shows how a unique product reference can be constructed depending on the desired options. Motor length, brake or no brake, STO, EtherCAT, Profinet or Ethernet IP field bus, and front or rear-facing connectors are all possible options. Only a selected number of model variants will be kept in inventory for fast delivery. All others will be made to order for large volume users. The table shows the product part number and features list of the motor drive shown on the picture. On this last slide are shown the 3 AGV kits that we make available to speed robot development. For small robots up to 500 kilos, the AGV060B bundles 2 60mm frame motors with gearboxes and wheels and an SBLG2030 dual-channel drive. For medium-sized robots up to 1,000 kilos, the AGV089A kit includes 2 89mm frame motors with gearboxes and wheels and an FBLG2360 dual-channel drive. For large robots up to 2,000 kilos, the AGV142A packages 2 142mm frame motors with gearboxes and wheels and a high-powered GBLG2660 dual-channel drive. This concludes our presentation. For product data sheets and support information, please come to www.roboteq.com. We are looking forward to succeeding together. Thank you for your attention. Welcome to this.
Okay, That was the presentation, and I want to add that we at Angst+Pfister, we have some samples of the Generation 4 available. So if you need samples, we probably have them, or we can order them for you. Volume production will be available soon. So if you are sampling now new applications, please feel free to order samples. And yeah, as I said, volume production will be available soon. Yeah, we already answered all the questions they came up. Again, thanks for your participation. We will summarize the questions and we will send each individual the answers to the question in more detail. We will store the video from today also on our website, so you can recapture what you have seen or heard. Yeah. Cosma, do you want to add something?
No, I just want to thank you all for participation. I'm glad you could join us. I would like to also to attract your attention again on that brake switch that you may have remember seeing was halfway through the presentation. This is something very new about how to stop faster, quite unique, and I know that we all need to make sure that the robot brakes fast enough. So if you're interested to discuss with us, I would like to engage and show you this product closer and maybe try it together.
Yeah. And again, if you have questions, please feel free to contact us, and yeah, we will try to answer, probably with the support of RoboteQ. So, okay. So if there are no additional questions, again, we want to thank you for participating, and yeah, we will close this webinar. We are perfect on time, even a little bit too fast, but I think everybody has enough to do. So thanks, and yeah, if you have questions, remarks, comments, please feel free to send to us. Thank you and goodbye.